Hello students, welcome to my channel. Today I am going to discuss about space complexity in design and analysis of algorithm. So the first step in design and analysis of algorithm is designing an algorithm. Design is nothing but creating. So we can create one algorithm by using natural language, pseudocode or flowchart. After creating an algorithm, we need to check the efficiency. So we can see when algorithm is efficient in terms of space complexity and time complexity. So if the space complexity is less and time complexity is less, we can say that the algorithm is efficient. So first we need to know what is space complexity. So in this video I am going to explain about space complexity. In the next video I will explain time complexity. So, space complexity refers to the total amount of memory space used by an algorithm or program. So, here we are talking about the algorithm. So, how much space the algorithm is taking. That is nothing but space complexity. Space complexity is also known as space efficiency. So, it includes the space of input values like variables and for execution. Okay. See, memory is required for the following reasons. So in a algorithm, the memory is required for the following reasons. The first one is it is used to the memory required to store program instructions. Okay, so the memory used to store program instructions. So here instruction is nothing but statement. So instructions are nothing but statement. Statement is nothing but the line which is ended with semicolon. Okay. For storing lines in program, we required memory. Memory required to store constant values. For example, 10, 20, 30 like this. Okay, hash define a is equals to 20. So 20 is a constant value. For storing constant values, we required memory. And memory required to store variables like int a, comma b, comma temp like this. So here a, b, temp are the variables. For storing variables also, we required space. Next one is auxiliary space is the extra space or temporary space used by an algorithm. So any additional space required for the algorithm, that is nothing but auxiliary space. Okay. So see this example algorithm. Give an array of integers, find the maximum element in the array. So for this problem, we developed one algorithm. After designing an algorithm, we need to analyze the algorithm. Okay, analyzing is nothing but checking whether it is efficient or not. Okay, so I want to check this algorithm is efficient or not in terms of space complexity. Okay, so space complexity is nothing but how much amount of space the algorithm is taking. Okay, so consider an array. ARR is a variable. It contains 5 elements. So in these 5 elements, I want to check what is the maximum value. Okay, so I am developing one algorithm. So the first step is start with max is equals to 5. So I don't know the maximum element. So that's why I'm assuming the first element is maximum element. So that's why max is equals to 5. Compare max with each element of the array. So compare max with every element of the array, every element of the array. So that's why if I compare 5 with 9, so 9 is greater than 5. So what is the maximum value? 9 is max. Next we need to compare 9 with 3. Okay, 9 is greater than 3. So 9 is max. 9 is greater than 7. 9 is greater than 2. So that's why no change. After that, return the maximum value. So after completion of this algorithm, it will return maximum value as 9. Okay. So next I need to check whether the algorithm is efficient or not in terms of space. So how to check? So the space complexity in this algorithm, we only need a constant amount of space regardless of the size of the input array. So here input array contains 5 elements. If the input array contains 10 elements also, it won't be a problem. Okay, so here we are using only constant amount of time for this variable. So which type of variable is this? This is integer type variable. Integer type variable uses constant amount of memory. Okay, so here it requires only 4 bytes of memory. Other than this, we are not using any memory. So see this, in this algorithm we only need to constant amount of space. Okay, we only need space for the variable max, which stores a single integer. So after completion of all these steps, it is stored only one value. It is storing only one value, that is nothing but maximum value. So we are using memory for this variable only. Okay. Therefore, the space complexity of the algorithm is order of 1, indicating constant space uses. So remember this, if the algorithm is taking constant amount of time, then we can represent the constant amount of 10 by order of 1. Okay, so order of 1 is used to indicate constant space. This means the amount of memory required does not grow with the input size of the array. So if the array contains 5 elements or 10 elements, this space complexity does not change. Okay, it uses only constant amount of time. Clear? So let's see the second example. Let's calculate the factorial of 5 using recursion. So first you need to know what is recursion and what is factorial. So factorial of 5 is nothing but 5 into 4 into 3 into 2 into 1, like this. What is recursion? Recursion is nothing but the function calling itself again and again. That process is nothing but recursion. Okay. So if you want to find out the factorial of 5 using recursion, first 5 into factorial of 4. So here factorial is a function. We are calling the function again and again. That is nothing but factorial. Okay, if you observe this, 5 into factorial of 4. Okay, we are calling factorial function and giving input as 4. Next 5 into 4 factorial of 3. Again we are calling. Next 5 into 4 into 3 into factorial of 2. After calling number of times, 5 into 4 into 3 into 2, it will return 120 answer. Okay, so here we need to check the space complexity. Okay, so for calculating the factorial of n using recursion, the space complexity is order of n. Remember this one, if one statement is executing number of times. Okay, so here the space is depends upon the n value. Okay, so if it is 5, it it calls the function 5 times. Okay, if it is 10, it will call the function 10 times. Okay, so based on the input value, the memory is increasing. Okay, the memory is increasing, so that's why the space complexity is order of n. Remember this, if the algorithm is taking constant amount of time, that is the order of 1. If the algorithm is taking based on the input size, if the algorithm is taking space based on the input size, that means n, we can say the order of n is a space complexity. This is because the recursion depth is n. Okay, so the recursion, the function calling itself based on the input size. If it is 5, it will call 5 times. If it is 10, it will call 10 times. As the function call itself recursively n times until reaches the base case. Okay, so that's why order of n. Clear? I hope it is clear. If you have any doubts regarding to this video, please comment me in the comment section. For more videos, please do subscribe my channel. Thank you.